So as a part of your session 2, this is the 8 session, and the title of this presentation will be on this advanced chemical thermodynamics and kinetics. So this is the tutorial session of Ref 18th March. So as usual in previous class we will also take some questions and its answer, and we will go through shortly. So this is the first question where this unimolecular reaction can be understood by radiation hypothesis, theory, and electromagnetic radiation, and none of these. So unimolecular means one molecule will react, one type of molecule will react, and that will give some intermediate, and that intermediate transition species will be go to the product. So this kind of reaction can be enhanced by this radiation. So among the three options, among the four options, A will be the answer. And coming to this question here, you need to calculate the rate constant of a reaction. So this is a very vital question, and you know this Lindemann Hinshelwood reactions. Hinshelwood. You need to apply this Hinshelwood reaction. So first you can try and you can thought that this kind of exercise is extremely important for understanding the basic concept of chemical thermodynamics. If you see the reaction of this, so 1 by k equal to k prime by k kb plus 1 by kb. So this is the equation, and for different pressure, just you let's say two different, if consider two different pressures, so corresponding is rate constant will be also different, and from there you can calculate the value for this p. Okay, so as you know there's rate constant, so the rate constant is second inverse is the first order reaction, right? So in first order reaction you need to get the value of this rate constant from the questions and followed by with the answer. So this so if you look at this value, this k and k prime, we need to find out this 1 by k equal to k prime by k into kb plus 1 by k into pa. So if pressure is for two different pressure, this rate constant will be also different, right? So 1 by k minus 1 by k prime equal to 1 by k into 1 by p minus 1 by p prime. So if you make a difference between these two, so 1 by k minus 1 by k 1 by p minus 1 by p prime equal to 1 by k prime, and depending on this, so you can get a value 1 by k prime equal to, so k prime is the rate constant, that means 1 by k will be the order of the time, that is the second, and from there you can find out k prime equal to 2.2 into 10 to the minus 4 second inverse. So for 25 Pascal, the rate constant is coming around 2.2 into 10 to the power minus 4 rate constant, right? Please let me know if you have any question to this, but you can just make a comment in the comment section while uploading in the YouTube videos. So basically, as you can see, this rate constant is inversely proportional to the pressure. If pressure is more, rate constant less. If pressure is less, rate constant more, right? So if you look at this problem, just a minute. So if you look at this problem, so it has basically this rate constant, which is basically if you have more the rate constant, less the value of pressure. So pressure and rate constant are oppositely like proportional to 1 by oppositely proportional. Now, so that means why it happens basically. So if we have more the pressure, that means less is the reaction rate. What is meant by more pressure? So if that reaction like patient 6, so molecules are randomly oriented and they make, so what is the pressure? Pressure is that per unit area how much force is exerted by molecules on the wall or erection facial, right? If that is more, that means they are not colliding with, the probability of colliding with each of the molecules is less, rather it's collide oil with the oil, right? That means the possibility of reactions is less because they are not colliding to each other. Not colliding means the possibility is more or less, right? Colliding. So as a result of which they will make more force or more, like they will collide with the wall, right? So the pressure will be more, but they are not itself, they are not reacting or not colliding. If not colliding or reaction, then reaction will not happen, right? In follow direction. So as a result of which the rate constant is also less. But if you take the reverse condition where rate constant is more, the pressure is less. Hope you understand. And for that case, the rate constant will be high because they are colliding with each other. So that means possibility for reactions will be more, right? So that is the reason that if you increase the pressure, then that means like fixed pressure obviously, then pressure will be less, head constant will be less, right? Okay, so with this go to the another questions where we'll talk about this concept called about this concept called so here you need to find out that how is the basically dependency of rate constant versus activation energy, right? So k equal to 8 it is so plotting just a minute, not this one. Here what you need to find out the k, we know k equal to a into e to the minus a by rt, right? If you take that log value and this, so what is that, right? Log k, sorry, log k equal to what? Log k equal to log of a minus e a by rt, right? I like always this area. So here also you already came to know log k versus 1 by t, right? So the temperature dependency, so the temperature dependency of a reaction depends on log k activation energy of the reaction can be calculated. Just if you plot a log k versus 1 by t, then it will be a negative slope, right? That slope value is the a value, that activation energy. So log k versus 1 by t, right? So your answer will be a. So answer is a, right? Here answer is a. A is the answer here. But in all of the questions we have noticed that they are related to either rate constant value or they are related to this energy of activation. So these two are the main parameters in most of the reactions. Now, if you look at this value, just so log k1, so A is the answer. Now, if you look in these questions, if you look the first questions where how the reaction happened, what is the activation for the reaction? So here radiation, right? Now, apart from radiation, light can also happen. So light is a radiation, right? By light also one can do the reaction. But if you go to the second question, where they are telling about the rate constant value, and that rate constant value is inversely proportional to this pressure. If pressure is more, then if pressure is more, then rate constant will be a little bit high. Yes, pressure is more, means rate constant will be less. If pressure is less, means rate constant will be more. So in question there is some concept why reaction happens. That is the first, you have to give the energy. Then okay, so rate is happening. What is the rate constant? This at per second, how much change in the mole of this product or of the reactant. But in the third question, okay, so you have this reaction is going on and reaction product is coming out, and what is this activation energy? How we can calculate the activation energy? Means R energy is A k equal to A to the base A by RT. If you take the log value in both sides, so you will get this value, right? So you need to plot log k versus 1 by t, where the negative slope is equal to about this activation energy. If you multiply it by 2.303, you will get this value of this activation energy. Okay. So this is the answer, that if you have a ln value of any parameter, then that is basically 2.3 into log into that value, and log k equal to log a minus ea by 2.303 rt, right? So if ln is if you take ln in both the sides, ln k equal to ln a minus ea by rt, that means 2.3. If you divide it by 2.3, the whole left hand side and right hand side, so you will get log k equal to log a minus ea by 2.303 rt. So if you take the plot between this log k versus 1 by t, that is the first option, so you will get a slope. That slope is a negative value. If you multiply that slope with 2.303 r, then you will get the value of this activation energy. We go to the other questions, where for a unimolecular reaction, none of which is the unimolecular reaction. So in most of the unimolecular reaction, you have this one type of molecule that will collide with each other, and that will make a intermediate, and that will go to the product, right? So if you just make a normal schematic to this, a plus a is giving you a star, right? And that a star is going to product. So to react A and A is going to be this A star, then from A star P is coming, right? So this is the only one molecule is happening in unimolecular reaction. Unimolecular reaction, that means one type of molecule, and that molecule will collide each other, and that will give to a transition state, and that transition state will give you the product. they can give a value around a plus a star by this. But if so, this is the first one. Why unimolecular reactions is just only one type of molecule is celebrating collision among each other, and that becomes the product. But there is two type of molecules, so you can't say this is a bimolecular. This can be bimolecular, but the order of a unimolecular cannot be one, right? May be different. Order is being considered or is being analyzed by Einstein's equation, but not this, only by this reaction scheme. So out of these three schemes, so for third one is this unimolecular reactions. Very important. So if you see, sorry, yeah, if you see this, so first you need to understand this reaction, what is the energy requirement. Then second question is all about this relation between pressure as the rate constant. If you increase the rate constant, that means your pressure will be less, and if you decrease the pressure, rate constant will be high, because this molecule will come to close to will come to each other and they will do react. Now coming to this, where you need to find out the rate of like activation energy, that can be calculated from this rate constant equation, k equal to a to the power minus ea by rt. Yes, so ln value can be written as log 2.303 log x. Now this is a reaction where this is all about this unimolecular reaction, and in the unimolecular reaction you need to find out this rate constant value. You need to find out this, which is the unimolecular reaction. And unimolecular reaction, only one type of molecule will be there, but the bimolecular will be two types. So there is no direct correlation between the rate of the reaction, order of the reaction, as well as this molecularity of the reaction. Molecularity is a pump is cannot be fraction. So there is a difference between molecularity as well as this order. So order can be positive, negative fractions, anything. But if you see this in this molecularity is always a positive number, and it is not a fraction. Okay. Sometimes they ask that they will give a reaction, then they will give a value that let's say this 3 by 2. Can it be the molecularity of the reaction? Answer will be no, this is not the molecularity of the reaction, rather this is the order of the reaction. Okay. Just a minute. Come to this question. So here is also again unimolecular reactions, and to find out the order of the reaction. So order maybe molecularity different, but order cannot be. That I have told that order cannot be can positive fractions anything, but it will be always integer and positive number molecularity. this is a molecular reaction where you have the value of this what I will say, in a chemical reaction at low pressure, what is the order of the reaction? That is extremely important. So I have mentioned that this order of the reaction depends on many things: pressure, concentration. So concentration for gas molecules, pressure and concentration both are same. So their concentration is measured at scale of their pressure, right? For gas molecules. So that kind of concept need to be applied here. So this depicted change of pressure, right? So change of pressure with respect to time, right? Like pressure change with respect to time. That is also right. If you see this, just say that all the data converted to storage bus. All the data converted as a class of storage. Or that all the data in storage space, so I can transfer possible all the data whatever you see. You check it. That's right. this today. Isn't much to look into also. Okay, where is this data? No, I should have other data also. Only all data are here, right? Mm. They took another two data, BSA, tail to pH. I don't know, is it? It is not here. No. Okay, got it. I will change this to another folder. Okay. Can I change it also? Yeah, okay. Thank you. Okay. 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 Thanks. So depending on the size of these, so here, as you know, this rate of change like for any molecular that I have time and again I mentioned the order cannot be particular fractions. Now it can be fractions, but the number of molecularity cannot be fractions, right? So for a so this is the standard equation for any molecular reaction where dPdt equal to Q1 K2 the concentration of A, concentration of M, K, and Kmm plus K2, right? You have to look what K2 is very very greater than K minus 1, so you can make Q1 into A into M. So the rate of the reaction is the second order, right? As you can see, the second order reaction, but written as unimolecular reaction, right? So in most of the case that K2 the order of the reaction is the second order reaction. Though it is a unimolecular reaction, but order can be more than one, that is the second order reaction. go to the next question, where this is a normal that an RRK model, rejection to RRK model by considering the 5% rotation 0.8. This one the answer will be. So if we recap, so this was our first question, unimolecular reaction, and so the first question on molecular reaction, this is all about this rate constant as well as pressure. How is the change constant in terms of changing in pressure. So this is coming about the this calculation of this activation energy EA value. Then this is for unimolecular reaction. This is coming at this at low pressure. How is the order of the reactions? So as you have seen that there's basically this is on this rate kinetics equate, like this is regarding this kinetics, chemical kinetics, and now if you go to this RK and RK model, this is a very important question. I need to calculate the 5 energy equal to 2 for ACL. Now this is a very important question, so I need to find out the value of this. Need to find out the value of this vibrational energy levels, right? So equal to 2, for me equal to 2. So in this case, we need to find out so there is a concept for reduced mass. So in reduced mass, so m1 m2 is a two is a let's say m1 m2 is a molecule made of two atoms, m1 and m2, and this ab, right, or 1 2, right? Now there is a bond between 1 and if you see this, hmm? Yeah. My bad, yeah. Now if you see here, anyone coming? Yeah, anybody is coming? My bad. So depending on this value, so this so means reduce not m1 m2 by m1 plus m2. If let's say m1 even greater than m2, m2, let's say m1 plus 1, right? So even for that corpus reduced will be more than, if m1 greater than m2, then obviously reduced will be more than this value, right? As far as it observes. So and from there this frequency equal to 1 by 2 pi k by root over k by mu. So 1 by 2 pi k by mu whole to the power half. So this is the value for this frequency, and from there if you calculate, so your this frequency is coming equal to 1 by 2 pi. Okay, let's calculate this k equal to 516 newton per meter. That is already there. You need to find out the radius, because that you know already. Same is, so 1 m equal to 1.6 into 10 to the power 1.6 into minus 27 kg minus 24 gram. So minus 27 kg, and for there you can get the value of radius by 1.626 into minus 27 kg. And from there you can get the value for this frequency, and frequency is coming around 8.96 into the power 13 hertz, and energy is coming h mu into mu plus half, so 148.42 into minus 21. So this is the energy 148.42 to the minus 21. Now if you take it, so here reducedness is a concept you is considered as well. We are not need to fill earlier questions, and you need to find out the reduced mass, and from there you can get the value of this parameter. Now you go to the other, so this h mu equal to h mu into v plus half, so that is the equation for energy levels for the electronic state. Now come for here, you need to find out this k unimolecular reactions, and this is basically the equation. Just a minute. This is the equation. I need to find out this k unimolecular reaction. So 1 by k equal to k minus 1 k1 k2 plus 1 by k1 into m, and y equal to mx plus c. So from this equation, so k un equal to 1 by k equal to minus 1 by k1 k2 plus 1 by k1. So this is the so this is the equation where you can find this k unimolecular reaction equal to k minus 1 by k2 is 2 to the power 5, and given slope is the plot of k universe versus 1 by mr 4 into 10 to the power 6, and what will be the value of intercept is. So 1 by k1 equal to 4 into 10 to the power 6. So this value k1 minus 1 by k2 equal to the power 5. So from here you can get a value of rho equal to mx plus c. So here intercept equal to k minus 1 by k1 k2. So they have given the slope and intercept, right, and this value. So from there you can calculate the intercept, k minus 1 by k1 into k2. So reverse like great question of the reverse reaction, and by q1 into multiplication of the forward reaction and the rate formation rate constant of the like product formation, right? So from there you can get the value of around 80 to 10 to the power 11. So this is the answer for 80 to 10 to the power 11. So A is the answer here. So now we need to find out another thing, that is you look at this, so this is the value 80 different value. So now you consider, you need to find out this k effective for this at higher concentration. So k1 is given, that is k1 is the forward reaction for the first reaction, that's n2O5 plus n2O5 is going to n2O5 plus n2O5 star, n2O5 star plus n2, it is going n2O5 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 stars, n2 n3, right? So for high pressure k effective is k1 into k2 by k minus 1, right? And k1 k2 is already given and k minus 1 is already given, so you need to find out k effective, right? So this value k effective is 10 into 10 to the minus 5 second inverse into 12 into 10 to the minus 5 second inverse by 5 into 10 to the minus 7 second inverse. So overall its k effective is coming at 24 into 10 to the minus 3 second inverse, right? So from there, so this is the key effective value we have already calculated. So now you need to find out another question, so where they have talked about to find out the value of this, like this is a strong collision RR theory on this is a strong collision. So now you need to find out this reaction rate for any molecular reaction under high pressure. So this is the second order, first order, first order, third order reactions. So in these reactions, you need to find out the for the any molecular reactions, what is the rate of the reactions. here if you see this, so the fast unimolecular reaction, this is on the rate constant as well as pressure, and this is on this activation energy barrier concept, and this one is also unimolecular reaction you have to find out. Therefore, I know what is the pressure for this reaction, and this is also a calculate for these vibrational energy levels. So effective is R, okay, this is the rate. So at high pressure, so if you look at the high pressure, so this is basically fast for us, so answer will be C here.